Hello everyone, welcome to our PUBG project by Helen, Julian, and Olivia. So for a quick overview, we're using PUBG dataset and training logistic regression model to predict whether a player can complete as top 10% based on its in-game statistic and initial player rating. And for our data cleaning, we're removing missing values and outliers. And for outliers, there are 4 criteria, and most of them represented the cheaters. And after the removal, we can see that we removed nearly 2,000 rows of data.
After dealing with missing values and outliers, we analyze the features by looking at the heat maps, which measures the correlation between features. We also look at the heat map for the 4 features that are most correlated with target. This gives us a preview of the features. Next slide. After that, we perform feature engineering. Based on our game experience, we think there are many hidden features in the data that are correlated with our target, and some features can be combined to be more meaningful. As there is no guarantee of there being 100 players per match, some features are not comparable in a match of different sizes. For example, kills. It is easier to meet and kill someone in a match of size 100 than of size 80. So it is meaningful to normalize these features based on number of players in the match. We will normalize damage dealt, match duration, max plays, and kills. And we combine boots and heals to items. Next slide. Then we split the data to 3 parts, train, test, and validation. And we further split them based on match type, as we believe that different match types should have different models with different features and weight. Next slide. For feature selection, we explore 2 ways to compare which one works better. Next slide. And first, we try a wrapper method, which is to use random forest classifier and select feature based on feature importance, which is measured as Gini importance. Then we use the package select from model to pick the threshold that gives the higher accuracy. And we will use this threshold to pick the important features. And the feature importance and the threshold are shown in the pictures. Next slide.
So with the important features that we selected in the last step, we are able to build a basic logistic regression model work as benchmark, which I will mention later on. In order to improve the accuracy of our model, we want to do a parameter tuning. Before we do that, we notice that our data contains imbalanced classes in terms of the labels, which is 1 to 9. We try to handle this issue by generating synthetic samples by an algorithm called SMOT. Would it increase ROC and AUC score? Let's give it a try. When doing the parameter tuning, we tune 3 parameters, includes penalty, C values, and solver. Among the 5 solvers, we picked the 3 most important ones, which are LBFGS, Saga, and SAG. Then we do parameter tuning on the dataset after we balance the classes. Here are the performance. We can notice that both AUC and accuracy increased in the better model comparing to the base model built by the benchmark I mentioned before. However, we're far from satisfied. We want to try better models. So we tested around and we want to see if we do not handle imbalanced class, what will be. It turns out that we got higher accuracy in AUC for the model without SMOT, so we will stick to it. Here is a quick recap of the steps that we did. Before I just mentioned the result we did on solo data, we also did the same steps on dual data, squad data, and full data. Those data sets represent different match types, and full data contains all of the data points. We can see that the accuracy are all kind of satisfying, but we will also test around other methods to see if we can get better results. Thank you.